can look at related to functions is net change. The net change is basically the change in outputs from an input A to an input B, where A is less than B. In symbols, that is f of B minus f of A. It essentially looks at how much the outputs have changed between two inputs. Let's consider something like f of x equal to x squared. And in this case, I want to find the change from x equal to 0 to x equal to 2. In this case, I need to plug in each of my values. 0 squared is 0. And 2 squared is 4. And then we subtract f of 2 minus f of 0, the bigger input minus the smaller input. In this case, my net change would be 4. Next, let's look at the change from -1 to 1. If I plug -1 into the function, -1 squared is +1. And if I plug 1 in, 1 squared is also 1. So my net change, f of b minus f of a, or f of 1 minus f of -1, will simply be 1 minus 1, or 0. Net change tells us how much it has changed from two particular x values. In this case, the x values are the same, so their net change has been 0. Let's look a little bit more at the domain. In this case, I want to consider the function f of x equal to 1 over x plus 1 times x minus 3. And if I think about what the domain is, what x values are allowed? And in this case, if we think about what x values we can put in, we might notice this division. In particular, we cannot divide by 0. So we cannot make the bottom of the fraction a 0. You'll notice if I input -1, I'll have 0 times -4, which would be 0. And if I input 3, I would have 4 times 0, which is 0. So in this case, my domain is x is not equal to -1 or 3. Any other values are fine, but inputting -1 or 3 is going to cause some problems. Next, let's look at something like f of x equal to the square root of 4 minus x squared. In this case, since we have a square root, we might think about how we cannot make a square root negative. What is underneath a square root must be positive. So we need 4 minus x squared to always be a positive or 0 number. For this to stay greater than or equal to 0, I essentially need 4 to be greater than or equal to x squared. This is primarily because that would make the 4 the larger of the two, and doing a larger number minus a smaller number would keep it greater than or equal to 0. And for this, we can see that -2 to 2 would allow this to happen. Squaring anything outside of this range will give outputs larger than 4, which would make 4 minus that number negative. So in this case, my domain is -2 to 2, or we can write this in interval notation. Finally, let's look at something like x over the square root of x minus 2. In this case, I still need my denominator to not be equal to 0, but I also need x minus 2 to be non-negative. So essentially, x cannot be 2, but it must be greater than or equal to 2. But since it can't be equal, we have the numbers that are strictly bigger than 2. And all of these are allowed inputs.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.